Hello friends, welcome in a lecture of Mechanics of Solid Subject. Today's lecture topic is a example of center of gravity. In this lecture, we discuss or solve the examples related to center of gravity for a composites elements. In last lecture, we already discussed the what is the center of gravity, how to find out for wire type elements, solid type elements, and plane type elements of center of gravity for that elements. So in this lecture we directly solve the examples for center of gravity for a composites element. Okay, so let's start. Example on composite linear element. So firstly we see the example for a composite elements, or we can say that linear elements only. It's a wire type elements, and we find out the center of gravity or centroid for wire type elements, and it's also composite type, means different geometry type wires are combined together, and this system totally system centroid we will be find out. Okay, so let's start. Find the centroid of wire A, B, C, D. A, B, C, and D. Okay. Now, firstly, we know that how we find out the center of gravity. We have an equation of x bar and y bar, and consider the reference axis is a point A, and from where horizontal and vertical reference axis. So, through this equation, we can find out the x bar and y bar value, and we particularly get the coordinates of center of or centroid of this composite wire element. Okay, so for this equation we have to first find out the L1, L2 and L3, three elements AB, BC and CD, then X, X2, X1, X2 and X3 for this three element, Y1, Y2 and Y3 for these three element. Okay, so first take the part AB. The length of this part is a 20 centimeter. Okay, now x bar for particular AB, that is indicated by xy, x1. Okay, so x1 of this element is a 10 centimeter, and y1 of this element is 0 because no any height from the reference axis of this element. So y1 is a 0. Clear? Now another part, BC part. So for that, length of this part is a 15 centimeter. It's given in figure. Okay. Now x2 distance of the center of gravity or centroid of this BC element from reference axis is a 20 centimeter. Okay, x2 is a, and y2 vertical distance is a half of 15 centimeter, so 7.5 centimeter. Okay, part 3, let's consider the part 3, CD. Okay, so length of this part is a 10 centimeter, and x3 is a distance of this centroid of CD element from horizontal and reference axis. For x is a horizontal distance from the reference axis of CG of CD. Okay, so it's a 20 plus 5, so it's a 25 centimeter x3 for CD, and y3 is the vertical distance from the reference axis of CG of CD. So vertical distance is a 14 centimeter, so y3 is a 15 centimeter. Now we have all values for these two equation, so put the all values in these two equation, and we finally get the value of x bar and y bar value, and this is the coordinate value of centroid for this composite element, and this is the 16.67 and 5.83 centimeter from reference A point. It is mentioned here. G point is a centroid of this element, composite element. Or composite elements means it's made with the number of wire element. So this composite element is made with 3 wire elements. Okay, so it's called the composite element. Okay. Now see the another example for a wire. Find the CG of wire shown below. The figure is given. Okay. So as per the procedure, we have two equations of x bar and y bar, and according to this coordinate value, we can get the CG or centroid for this composite element. We have two elements here. One is a BC and CD. Sorry, 3 element. We have a 3 element. One is a AB, second is a BC, and third one is a CD. Okay. So first element length is a 20 centimeter, and the reference axis is considered from the A point. So CG of AB is at mid of AB. So the vertical distance y1 is a 10 centimeter, and the horizontal distance is 0 from the reference axis, because it has not any distance of AB from reference point or reference axis. Okay, so it's a 0. Now for a BC element is a arc, wire arc. Okay, so we know that what is the length of arc is a pi r. Okay, so means actually is a 2 pi r by 2, so 2 cancel, and it's a pi r. This length or equation or area equations or CG of particularly specific shapes are already discussed or mentioned in the last lecture in the form of tables. We saw the tables of areas of planes, wires, length of wires, equations of length of wires, areas of planes, and volume of solids. And CG of these all elements are mentioned in last lecture. So you have to memorize to solve this equation. Okay. So here the length of wire is a 31.4 centimeter. Okay. Now CG of this element is at here. Okay. So x horizontal distance of CG of this element to reference axis is the r. So it's a r is a 10 centimeter. So x2 is a 10 centimeter. But the vertical distance from the reference of CG of BC element is 20 minus 2r upon pi. 2r upon pi is the distance of CG from the base BC. Okay. So 20 minus 2r upon pi means this is minus from this length. Okay. So it's a 13.63 centimeter. 2r upon pi is a distance of CG of BC element from the base, from the BC line. Okay. So it's minus from the 20. So we get the vertical distance of CG of BC element from the reference axis. It's a 13.63. Okay. Now consider the part CD. It's a straight line. Again. So length of this 5 centimeter. X3. CG of CD, the distance of CG of CD from the reference axis, horizontal axis, is a 20 plus 2.5. Okay. So x3 is a 22.5 and y3 is a 20 centimeter, perfectly vertical distance from the reference axis is the 20 centimeter. Now we have all values of these two equations, L1, L2, L3, x2, x1, x2, x3 and y1, y2, y3. So put the all values of these two equations and find the value of x bar and y bar, and this x bar and y bar value decide the coordinates of the CG for this composite element from the reference point. Okay, according to reference point, CG is horizontally 7.5 centimeter is here, and vertically vertical distance of CG from the reference point is 12.91. So we get the CG value of this composite wire diagram. Okay, let's take the another examples of wire diagram. Okay, this is the triangle. See the what is say to find out the CG. Find the centroid of wire making an equilateral triangle of 4 centimeter. Instead that, find the CG of this wire which making equilateral triangle of 4 centimeter. So each side of triangle is a 4 centimeter because it's an equilateral triangle. So the side of triangle is same. So it's a 4 centimeter all three side. Now we have a three element AB, BC and AC. So according to this equation, we find out the value of L1, L2, L3, x1, x2, x3 and y1, y2, y3. But here for bar x, this equation is not put, directly is find out because it's a symmetrical geometry from vertical axis. So vertical geometry, symmetrical area or line or geometry having a directly find out this x bar because it's a symmetric from the vertical axis. So we get the directly x bar, it's half of this width is a 2 centimeter. So x bar is directly find out of this vertically symmetrical composite elements, even if it's wire diagram or even if it's plane or even it's solid. So all in this case we directly find out the x bar and y bar. Okay, so x bar is directly find out the half of this 4 centimeter is a 2 centimeter and the reference axis is a B. So triangle of CG is placed it here. So the horizontal distance is a half of the this BC line. Okay, so it's a 2 centimeter. X bar is a. Now we have to find out the y bar. So only we have to find out the value of y1, y2 and y3. Not want to find out the x1, x2, x3. So L1, L2, L3 is the same 4 centimeter. Now we have to find out the value of y1 for AB line. So it's a vertical distance from the base. So find out with the help of trigonometry. Make this triangle and this angle is 60 degree angle because it's an equilateral triangle. So all angle of 60 degree. Okay. So according to this triangle and this angle is a 60 degree. Okay, according to this triangle we find out this vertical length and the angle is 60 degree, and this length we already know that this is the half 2 meter. So angle and 2 meter is known. So this vertical distance is find out with the help of this sine equation. Okay, sine is equal to sine 60 is equal to y1 upon this slant phase is a 2 centimeter. Okay, so y1 value is a 1.732 centimeter. Now for BC, from the reference value, and so the reference axis, the vertical distance of this CG is 0. So y is a 0, y2 is 0 for this element. Okay. Now for a third element SE, the y is same because it's an equilateral triangle. So it's a 1.732 centimeter. Okay. So now put the value of L1, L2, L3 and y1, y2, y3 in this equation and get the value of y bar. We already have x bar, so we find out the y bar value, and now we get the value of CG or centroid for this equilateral triangle. Its place is here and its coordinate value is a 2 centimeter or 1.55 centimeter, 2 centimeter away from the horizontally and vertically 1.15 centimeter from reference point E. Okay, sorry, B, reference point B. Okay, clear? In this sum, you can take a reference as any point A, B, C, anyone. Here they assume that this is the reference axis. You can also consider this C point as a reference. Okay, the answer will be the same. Now determine the centroid of wire bent as shown in figure. Okay, now we have to find out the value of centroid. So we have equation, and here is a two element, so only L1x1 and L2x2 is there in this equation, and we have to find the value of L1x1 y1 and L2x2 y2 for these two element. One is the arc element and another is the line element. Okay, clear? Now the first element is the arc. The value length of arc is a pi r, so r is a 5 centimeter, so length is a 15.71 centimeter. Now the CG of this arc from this reference point is of distance of diameter is at a radius 5 centimeter, and the vertical distance of CG for this element, arc element, from the base is 2r upon pi. Okay, so this equation you have to memorize. The arc CG's distance from the base is 2r upon pi, and this distance we have to find out 3.18 centimeter is a y1. Okay, and this point is the reference point from where we have calculated the x1 y1, x2 y2. Okay, now the second element, the length is 10 centimeter. Now the x2 is a CG is half of 5 centimeter plus 10 centimeter is a 15 centimeter x2, and distance of 5 is a 0. Okay, from the reference axis, vertical distance is 0. Okay, so y2 is 0. Now put the value of all elements in these equations and we get the value of x bar and y bar for this composite element, and this x bar and y bar value giving the coordinates of CG or centroid of these composite elements from the reference point. Okay, this is the reference point. Okay, from that we have to find the value of coordinates value of centroid. Okay, x and y. Okay, x bar and y bar. Clear? Now again another examples. Here the quarter wire is considered. This is the last example for a wire composites element. So here is a one element is a straight line and another element is a quarter of circle. Okay. So two element is here. So the equation become L1x1 plus L2x2 upon L1 plus L2, and here y bar equation L1y1 plus L2y2 upon L1 plus L2. Okay. So we have to find out the L1 x1 y1 L2 x2 y2. Okay, for both elements. Clear? Here the mistakes, here L2 x2 and y2. Okay. Now consider the straight line element AB. The length of element is a 2 meter. Okay. Now the CG of AB is in middle. So this slant length is a 1 meter, and the vertical distance from the reference point we have to find out. Sorry, this distance is given 0.586, and we have to find out the distance of CG of AB to this line. Okay. So we consider the triangle, and according to triangle we find out the vertical distance. Here the length is 1 meter, angle is a 45, so we get the value of this is a 2 cos 45 and is a 1.414. So the total vertical length of this CG of AB is a 0.586 plus 1.414. Okay, clear? So the total y1 value is a 1.293 meter. Okay, clear? Now consider for the quarter, the CG is at here something, at assume that it is here. The distance of CG from these two side is a 2r upon pi, and this distance is also 2r upon pi. Okay. The length of this quarter wire is a pi r by 2. Okay, or we can say that 2 pi r by 4th. Okay, so 2 cancel and pi r by 2. The length of this quarter wire is a pi r by 2. So r is given 2 meter. So length of this quarter wire is a 3.14 meter. Now x1 is 2r upon pi plus this horizontal distance is a 1.44. Okay, horizontal distance is a 1.44. Clear that? This is find out at here. Okay, and you can directly find out with the help of this triangle. Okay, this is the 2 meter, and this is the 2 meter, and angle is given. So this AB dash line length is find out. Okay, it's a 1.441 and 1.44 plus 2r upon pi for a x1 value, and the y distance is a 2r upon pi. Okay, so it's a 1.273 meter, and x2 is a 2.68, 1.44 and 2r upon pi. Okay, clear? So now we have all values L1 x1 x2, L1 L2 y1 y2. So put the all values in this x bar equation and y bar equation, and we get the value of x bar and y bar. It's a 1.9 and 1.2 of x bar and y bar value. It's given the coordinates of centroid from this reference point or reference axis. This reference axis distance of CG. It's here. Okay, clear that? It should be at here, something there. CG. Okay, clear? Now this way you can find out the centroid by these two equations, x bar and y bar equation, and for that you have to find out the all element CG distance from the reference axis in the horizontal distance and vertical distance of CGs of all elements from the reference axis. Okay, and the length of all elements. So you can easily get the x bar value and y bar value, and it's given the centroid or CG of these composite wire elements. In wire elements only the length is considered because its diameter and height, means height or width, is very negligible. So only length is considered for the wire type diagram. The width and height is negligible for that wire. Okay, so the only length is considered for the wire type diagram or wire type elements. Okay, clear that? So the only length is considered to find out the center or CG for wire type geometry or wire type elements. Only length is considered. The width and height is negligible for the wire type element. Okay, clear? I hope that you very well understand how to find out the centroid or center of gravity of wire type elements or wire type composite elements, and in next video we will solve the examples related to center of gravity or centroid for plane type elements, find out the CG for plane type elements, and also discuss about the how to find out the CG of solids element and Pappus-Goldinus theorem for the symmetric solids, and how to find out the CG with the help of these principles. Okay, I hope you very well understand, and thank you for listening this video. Okay, thanks.
Center of gravity. Try to balance a piece of cardboard on your fingertip. What do you observe? We observe that there is only one point on which the cardboard can be balanced. This point where the cardboard can be balanced is called the center of gravity of the cardboard. Thus, the center of gravity is the point through which the resultant of the weight of all the particles of the body acts. Let us now determine the center of gravity of an irregularly shaped lamina using a plumb line. Make 3 holes near the edge of the lamina so that the lamina can swing freely when pivoted from each hole. Suspend the lamina from the point P as shown here. Hang a plumb line from the point P and mark the plumbing line P' on the lamina. Repeat the experiment by suspending the lamina from Q and mark the plumbing line Q'. Now follow the same procedure for the point R. We observe that all the 3 lines PP', QQ', and RR' intersect at one point. This point where all the 3 lines meet gives the center of gravity of the lamina. Generally, the center of gravity of geometrically shaped objects lie at the geometric center of the object. View the center of gravity of the objects listed here by clicking on the objects.